We demonstrate in this video our inverse blending framework for motion parameterization with spatial constraints. In the first scenario, inverse blending is used to parameterize a pointing motion database. The center of the manipulator is set as the pointing target, which specifies a 3 degrees of freedom positional constraint. The character is able to precisely pinpoint to any given target with fingertip within the workspace. Each motion is interactively generated within milliseconds as target position changes, and great precision is achieved. Our database contains 35 example motions. Each time inverse blending uses 13 motions for the synthesis, and the constraint can be very well satisfied within a fairly large volume around the character. In the second scenario, we synthesize motions of pouring water at different locations. First, motions are parameterized by specifying a 3 degrees of freedom positional constraint at the center of the manipulator. With less example motions and variations in the database, the constraint is reduced down to 2 degrees of freedom to become a line constraint that can be better enforced. This requires the bottle to be on the green line above the teapot. Inverse blending then yields even better results. In the third scenario, we demonstrate an interactive local motion generator with precise feet placement using inverse blending. The character in the middle simulates the walk sequence. The 2 gray skeletons with stepping legs marked red compute left stepping and right stepping motions respectively, precisely placing character's stepping foot on the target for each step. Each step is computed with 2 constraint vectors specifying the start and end locations of the stepping foot, plus a rotational constraint for the support foot that maintains contact on the floor. The current step is generated using left stepping inverse blending solver. The orange arrow indicates the constraint vectors towards the end location for left foot placement. The whole local motion sequence is concatenated with alternating left and right steps. Each step is solved at the last frame of the previous step. Future step location constraints can be adjusted interactively on the fly, and the locomotion follows the changes instantaneously. Our database contains only 6 example motions with great variations for each foot. This is a playback of all the examples. The final locomotion synthesis on the skin character. The constraints are very well enforced for each step. For a close look at the steps, there's absolutely no feet sliding on the floor.